This video is covering Pre-Calc Notes 2.2. We're going to be looking at polynomial functions of a higher degree, so meaning degree 3 or degree 4 or even degree 5. And the first thing I want to do is kind of just look at the general shape of these graphs, and then we will talk about how the number of turning points that are involved in it and the general shape, whether it's opening upward versus downward, whether it's the left side is rising and the right side is falling. And we're going to make those characterizations after we take a look at these three different graphs. So you'll notice the first graph that I have in the graphing calculator is 2x to the third plus 1. So here's what the graph looks like. When it's degree 3, you're always going to see this S-like shape of the graph. And when you have the graph with a positive leading coefficient, in this case a 2, your graph is going to rise to the right and fall to the left. Let's take a look at what happens when I change this to a negative. So you'll notice that now I have changed the graph to a negative 2x to the third plus 1, and now the graph has changed in terms of it's still an S-like shaped graph, but the right side is falling now and the left side is rising. So we're going to write that characteristic down in the table here in just a moment. Next thing I want to do is I want to take a look at a degree 4 polynomial. So if I put that in the graphing calculator and we graph it, we're going to get a graph that looks like this. And you can kind of compare this to the shape of a W. And it is opening, or I should say both of the ends of the graph are rising. They're both going towards positive infinity because of the fact that my leading coefficient is positive here. Again, if I look at the graph and I change it to a negative, so if I insert a negative sign in front of here, let's see what happens to the shape of my graph and the direction of it. You're not going to be able to see all of it because some of the graph goes off, but the graph starts way down here, comes up, makes a loop back down. So now instead of it being a W, it's more of an M-like shaped graph. Both of the ends are falling when we change the leading coefficient to negative. So we'll make that characterization down here in just a moment as well. Let's change now to degree 5. So if we look at the graph of a degree 5 polynomial, this also is going to have an S-like shaped graph. You'll notice here's my S-like shaped graph with the right side rising, left side falling. So degree 3 and degree 5 look very similar. And we would expect, if I change this to a negative leading coefficient, that the graph should change directions in terms of the left side rising and the right side falling. Again, S-like shaped graph. You'll see it's a little bit more curvy this time, but it still has the same characteristics in terms of the left side is rising, the right side is falling. And so we need to know, just by the degree that our polynomial is, 3, 4, or 5, and the leading coefficient, what the general shape of our graph is going to look like. So let's actually start to fill this table in with that information. So we said that if it was an x to the third with a positive coefficient, that the graph looks like this. It'll be S-like shaped graph with the right side rising and the left side falling. If we change it to negative, that's just going to change the shape of our graph in terms of the left side falls and the right side rises. I said that backwards, excuse me. The left side rises and the right side falls. When it was an x to the fourth power, a positive coefficient, we had a W-like shaped graph, so something like this. And when we changed it to a negative leading coefficient, it was more of an M, so a graph that would look like that. And when it was a degree 5, again with a positive coefficient, it looked just like degree 3, and a negative coefficient would look just like degree 3 negative leading coefficient. And in the last section, we actually already discussed an x squared graph. We know that that's a parabola. When the leading coefficient is positive, you're going to get a U shape. When it is negative, you are going to get a upside down parabola. So it's important for us to know that this is going to be U-shaped, this is going to be S-shaped, this is going to be W-shaped, this is going to be M-shaped. this is going to be S-shaped. And I think just by kind of looking at the way we draw those letters helps us to evaluate what our graph should look like. I would expect that you would know these different shapes of the graph and not have to plug them into your graphing calculator to get that. It's important that you know the general idea of what the graph will look like, and then you can go back to the graphing calculator to get a more exact view of it. One of the common themes that you should have noticed in that chart is that depending on what your leading coefficient is, what your degree is, what the highest degree is, will tell you how many zeros that the polynomial should have, but it also will help you to identify the number of turns of the graph. So when it was degree 2, when we said it was an x squared graph, it would result in a parabola. And so notice that when the degree was 2, the number of turns, it starts off going down and then it changes directions here and it goes up, is 1. So the number of turns of the graph is 1 less than the degree. That's most of the time. You'll notice that sometimes when we have an x to the 5th polynomial, it gives us an S-like shaped graph like this. We don't always get 4 turns. Sometimes we will, but most of the time we're going to get only 2 turns, sorry. But this is a general rule that usually you're going to get 1 less than the number of whatever the degree is for the number of turns. So keep those in mind when you are making your graph, that the degree of the polynomial will tell us the number of zeros. So when it's an x squared, it should have 2 zeros. When it's an x to the 3rd, it should have 3 zeros. And the number of turns is given by the 1 less than the degree. So if it's an x to the 3rd graph, so that's what you pay attention to first, the leading coefficient test will tell us that the number of turns our graph should be 2, so it's 1 less than 3, and the number of zeros would be 3. So this graph is going to look something like this. It's going to be an S-like shaped graph. That's the left side is falling, the right side is rising. So I just drew a generalized shape of that. I can actually look at the actual graph of that and notice that it's touching the x-axis in 3 different spots, hence the number of zeros. And the number of turning points would be 2, because notice that my graph, if I start on the left side, it's rising, and then right here, it turns, and it starts to fall. And just out of the picture here, you don't see the exact point, but somewhere around here, it's changing direction and going up. So this, I'm just going to put a TP next to that for turning point, and a TP next to that for turning point. So this is what the actual graph looks like. I could come up with the general shape of that just by knowing that the leading coefficient was positive and that it was an x to the 3rd polynomial. So let's do the same thing with the next example, and then let's look at the graph to see if we have the generalized shape of that graph correct. Okay, so the leading coefficient test for this one, it's an x to the 4th, so I know that it's going to be a W shape, and it's going to be going up because of the fact that it's positive and not negative. So I'm thinking the graph is going to look something like this. Again, I'm just randomly putting that on there. That's not exact, but notice that the number of turning points that my graph should have, 1 less than 4 would be 3. The number of zeros should be 4. Let's check that with our actual graph on the graphing calculator. So let's first talk about the turning points. So turning points, it starts way up here, it comes down. There's one turning point. Then it comes up here, and there's another turning point. And then, again, out of our picture, this graph is going to still go down something like that. And then that would be another 3rd turning point. So we do have the 3 turning points, which is what we expected. Number of zeros, it actually only looks like there's 3 zeros. You're going to get a 0 here and here. But actually right here at x equals 0, there's actually 2 zeros there. It's a repeated 0. So you actually do get 2 zeros there. A lot of times when the graph changes directions and it touches the x-axis, you're going to see that a repeated 0. So you actually do have 4 zeros also. Let's actually go back to one of the examples we looked at a second ago and actually graph one of these. Before I make my graph, and you'll notice that I'm not showing you it in the graphing calculator on purpose, I know that the general shape of this should be an S-like shaped graph. Leading coefficient is positive, so it's going to rise to the right, fall to the left. So I'm thinking I should get a graph that looks like that. Using the graphing calculator, we can see what our values are in our t-table. So at -3, it'd be -18, 0, 4, 0, -6, -8, 0, and we can't actually see, but at 4 it's going to be 96. Actually, I take that back. I was looking at the wrong value there. At 4 it should be 24. So let's go ahead and plot this. Obviously I'm not going to be able to plot -3, -18. My graph doesn't go down that far. But I know that it's going to start down here somewhere. So I'm just going to put a dot down here to remind myself that my graph has started down there. And then the next one at -2 is 0. At -1 I'm at 4. At 0 I'm at 0 again. At 1 I'm at -6. 1, 2, 3, 4, 5, 6. At 2 I'm at -8. At 3 I'm back up at 0. And at 4 I'm at 24. Obviously again I can't plot that on my graph, but I know it's going to be way up here somewhere. So my graph will start way down here. It'll come up to this point where it will turn. So there's one turn. It'll come down, keep going down until it gets to this point where it will change directions again. So that's 2 turns. And it'll come all the way up here. And so notice that just by coming up with this generalized shape, I know that I have enough points here. If I didn't get the turns like I have for this graph, I may have to change the values that I pick in my t-table. And so that's why I wanted to show you this, that you need to pick values in your t-table that are going to give you your 3 x-intercepts, because it's degree 3, and your 2 turning points, because again it's degree 3, and I know that the general shape of this should be this S-like shaped graph that rises to the right and falls to the left. So most of the time you can pick values from probably usually -3 to +3, but if you're not getting your turning points and your zeros, you may have to pick values in between here. So for example, maybe -2.5 or -1.5. It just depends on the graph that you have to figure out what your turning points are. If you're struggling with coming up with the points, a good thing that you can do is you can actually calculate the x-intercepts, and that's going to also give you an idea of the points that you need to put on your graph. So let's do that with this this problem. If I want to find the x-intercepts, that's when the y value is equal to 0. So what I'm going to do to solve this is factor out the greatest common factor of x. So if I take an x out, I'm going to be equal to x squared minus x minus 6. And I can factor this now by saying what multiplies me -6 and adds me -5. I know it's got to be 3 and 2, and they both have to actually be negative. Let me start over with that because I don't know where I was getting the -5 from. What multiplies to be -6 and adds to be -1. And it's going to be 3 and 2, where the 3 is the negative and the 2 is positive. That's better. So this would factor down to be, don't forget to put the x from here. Break this down into be x minus 3 and x plus 2. And then what I can do is I can set all 3 of these individually equal to 0 to find my x-intercepts. So x would be equal to 0, x minus 3 equals 0, and x plus 2 equals 0. So I've got 0, I have a positive 3, and I have a -2. So let's just verify that with my graph. Isn't this -2? This is 0, and this is 3. I've got those 3 values on my graph. So again, in terms of helping to pick what points I use here, most of the time we can pick, numbers from -3 to +3. But we always want to make sure we include enough numbers to show our x-intercepts, in this case from -2 to +3. And we also want to pick numbers that are going to get us to our turning points. So that's why I chose these numbers here. It wasn't just putting the numbers on there and seeing what works. you want to be very careful about the numbers that you pick when you're graphing these.